All right, welcome back. We are up to lesson 8 now. And in lesson 8, and actually this will continue in lesson 9, we're going to talk about stretching and squashing. So, in this particular lesson, we're going to focus on vertical stretching and squashing. And that is when all of our output values are multiplied by a constant. Okay, so all of our outputs, all of our y values are multiplied by a constant. So that will look like this in terms of function notation. The key is with vertical, we don't do opposites. Just like with vertical shifts, we don't do opposites. Okay, so it goes outside and we don't do the opposite. So if the number that you're multiplying by is greater than 1, then that's going to be a vertical stretch. And then if it's less than 1, it's going to be a vertical squash or compression. With horizontal, it's going to be just like horizontal shifts. So you're going to do the opposite, okay? Except now all the inputs are being multiplied by a constant, okay? You're going to do the opposite on the inside. So a stretch, which would normally be positive, is actually going to be multiplying by something less than 1, so on and so forth. But like I said, we're going to focus on that in the next lesson. In this lesson, we're just going to talk about vertical stretching and squashing. So let's go right ahead and go to the examples. So the Holmay Arch Bridge in Manchester, England is shaped like a parabola. The ends of the arch are 52 meters apart and it is 25 meters high. Use the description to help you label the coordinates on the graph. Okay? This point right here is going to be easy. That's going to be 0, 0, right? Okay? This one is going to be 52, 0, because the ends are 52 meters apart. Okay? This one, it is 25 meters high, so that means the y value is going to be 25. The question is, what is the x value going to be? Well, the x value, remember, with a parabola, the high point or the low point is halfway between the x-intercepts. So the x-intercepts are at 0 and 52. Halfway between them is 26. So the coordinates of this point is going to be 26, 25 because it's halfway between those x-intercepts. So that's the answer to number 1. Number 2, Han wants to model the shape of the arch with the graph of a function, and he chooses h of x equals x times 52 minus x, where h of x is the height in meters of a point x meters along the base of the arch from the left end. A, for the x coordinates of the 3 points, what are the corresponding points on the graph of h? So we're going to graph this h function, x times 52 minus x, and that's going to look like this. And you can see for my two x-intercepts, notice the two x-intercepts stay the same, 0, 0, and 52, 0. But notice the height of this graph. Whoops. Notice the height of this graph is not 25 meters, it's 676 meters. So for A, the 3 points are going to be 0, 0, 26, 676, and 52, 0. So the two x-intercepts are the same, and then the high point is at 26, but the actual height is not 25 meters, it's 676 meters. So that actually answers part B. What aspects of the graph does Han's function model well? Well, what does it model well? It models the x-intercepts well. And what parts does it not model well? So not well, it does not model the height of the arch. Okay. Compare the height of Han's graph with the height of the Home arch. So the arch has a height of 25 meters, and Han's graph has a height of 676 meters. And this is part C. Okay. How can you change the outputs of H to make it fit better? So if I go back to the graph, okay, I need to change this height. I need to change this output to make it model the height of 25 meters better. I can't just go ahead and shift it down, because if I shift it down, then that's going to change the x-intercepts, okay? That's going to change the x-intercepts. That's going to cause these y values to move down as well, and that is exactly what we don't want. So the only way to do this is to compress it vertically, to squash it vertically. So with a vertical squash, that means I have to multiply the outputs by a value. So which means I have to multiply 676 times something so that it becomes 25. So I have to do a vertical squash. Okay? If I multiply these y values by any number, anything times 0 is 0, so those won't change. So what I have to figure out is, what do I need to multiply 676 by? What is that C value going to be so that I get a height, my desired height of 25? So I created an equation. 676 times C equals 25. Okay? So I can solve this by dividing by 676. Now, obviously, 25 divided by 676 is going to be a decimal. So my C value is going to be 676. So I'm going to do a vertical squash. The way we're going to describe it is we're going to do a vertical squash by a factor of 25 over 676. Okay? With vertical squashes and vertical stretchers, we don't do the opposites. So a vertical squash by a factor of 25 over 676. So h of x is going to be equal to f of x. And the way we're going to write our function notation, okay, because it's a vertical squash, we're going to do it outside, so times, and we're not going to do the opposite. So times 25 over 676, okay? So my equation is going to be x times 52 minus x times 25 over 676. And if I change that, if I do that, let's see what the graph ends up looking like. Okay. So if I were to change this to x times 52 minus x times 25 over 676, well, what happens here? Notice I get the right x-intercepts, and what do you notice? The high point is at 25 meters. So it models that arch correctly. Okay, so this was a vertical squash or a vertical compression. In our next lesson, in lesson 9, we're going to talk about horizontal squashes and horizontal compressions.